Welcome back. As I mentioned in the previous video that this particular video is going to be an extension of the concept of learning how to determine protons, electrons, and neutrons. But you got to keep in mind the element as you see in the periodic table and how the element actually appears to work in the real world are two different things. Okay. When we determine protons, electrons, and neutrons in the previous video, that's for a pure element in its elemental form, or also known as neutral. However, most elements in a compound has to convert itself into an ionic form if it's a metal. But again, that's a different story. But anyways, it works. It has to transform itself into a different form. And a lot of the times, a lot of the compounds we see are ionic in nature. Okay, so we have to learn about positive and negative ions and how that influences the count of either electrons, protons, or neutrons. Okay, so positive and negative ions. Okay, along this video, I'll keep it very short, but I also give you some important trivia that you can remember, because every time we're going to come back to this concept, you need that knowledge. Okay, pay attention to these two terms that are underlined, because I'm going to have a pop quiz which is not graded, but see if you can get it wrong. Okay, if you're brave enough, stop the video, get the answer, and then try continue watching the video. Okay, positive ion typically refers to an element that's lost an electron or electrons, a singular or plural. Some elements can lose more electrons while others can only lose one. So you would see this type of writing throughout the course. Okay, chemistry is not one size fits all. Every component has its own logic, and that is part of the problem why learning chemistry can be difficult. Okay, and is also known as a cation. Okay, cations are positively charged, and positive charge means an element has lost an electron or electrons. Negative ion is the element has gained an electron or gained electrons. It's also known as an anion. Now that is simple. Okay, this is a fact. No matter which professor comes and talks to you, he's not going to give it to you any different than what I have given, because this is factual information. It may appear different in Germany or French, but this is the information. Now here's a pop quiz for you. I told you to pay attention to the statements above. All right, when an element goes from a neutral state to a positive or a negative ion, which of the following statement is true? Now, conventional to orthodox lecture, where someone simply just talks for an hour and a half, I've designed this. And again, we're being in an online environment. You do need that extra bit of support, because we're not always seeing each other, right? Now, if you don't understand this quiz right away, that means you haven't really paid attention to anything I have said, which means you need to pay more attention to what the person is narrating in the video. Now, as I said, this is not graded. This is the way learning has to be treated so that it actually makes sense. And the answer that for the delay is choice A. Okay, what do I say about how did I even define positive and negative ions? Positive ion means an element has lost electrons, or a negative ion means gained electrons, or it's gained an electron, right? So whenever an element goes from a neutral to a positive or negative ion, only the electron count is different or is disturbed. Okay, typically this is a trivia which I will come back again and again and again, would point this out, because some people just have a problem with what's on the screen. I don't honestly see what is confusing here. There's enough space between terms, everything is underlined, different color coded, but for some reason this information seems like overload. So that's why I'm going to keep this video to this and then one problem. Okay, typically metals form cations, that is, metals tend to lose electrons, and non-metals typically prefer to form anions. There are exceptions to it, but that is pretty rare. Metals can never make anions, that is, metal cannot ever gain electrons. Okay, Non-metals can do a little bit of both, but let's just keep it for the normal case. No exceptions will be taught in this class. Typically, metals form cations and non-metals make anions. All right. With that said, let's wrap this video up with actually learning how to make the electron or proton or neutron count. Okay. So here we have a magnesium, as let's say, it's gone from a neutral state to Mg2 plus. This is what I will give you. Okay. You have to get this information from the periodic table. I give you determine the number of protons, electrons, neutrons in magnesium. I know that the atomic number corresponds to the number of protons and electrons, right? Now here's the trick. It's very easy. It's not a trick. It's science. Okay. So atomic number is 12. So we got 12 protons because when an element goes from neutral to positive or negative, it has no influence whatsoever on the number of proton count. But we had 12 electrons originally, right? That's what Mg neutral means. But we have +2. Every plus corresponds to 1 electron being lost. So 1 plus equals to 1 electron lost, because positive means electron lost. So now we have only 10 electrons. Now we're not being very specific which orbital the electron is lost. That is the next series of videos. Here we're understanding the idea that positive means electrons are lost and it makes a cation. Negative means electrons are gained, so it makes an anion. Okay, we're not actually distinguishing where the electron is lost. That is very, very important, but that is the next step in the learning process. And neutron count is never bothered. It's just the same way. So number of neutrons would be, you see this number again is, less than 0.5, right? Less than 0.5. So you round below, right? And so that would be 24 minus 12. So it'll be 12 neutrons. So to wrap this up, is 12 protons, 10 electrons, and 12 neutrons. And what is this called? It's called a cation, because you were not specifically asking what is this. You can say magnesium cation, but it is a cation because it's positively charged. Let's wrap this up with one more example. Now, if you remember, magnesium is an alkaline earth metal. You don't need to say alkaline earth, it's a metal. Okay, phosphorus is in the non-metal family. So if you remember the tip, non-metals typically gain electrons, metals always lose electrons. And that makes sense because it's got 3 minus. And phosphorus atomic number is 15. So it's got 15 protons and it had 15 electrons originally. Now I started doing this a few years back because I think this really, really drove the point into the ground where I don't think anyone got this question ever wrong on any of my exams from that point onwards when I did this type of math rather than actually writing 10 here with a bit of oral explanation. As I said, chemistry is still a visual subject. So we have 3 minus. 1 negative equals to 1 electron gained. So that means we have now 18 electrons, and don't add negative or any kind of nonsense, just leave it this way. And then number of neutrons would be, this number is greater than 0.5, so you round about, that is you round about to the nearest whole number. So it'll be 31 minus 15 would be 16 neutrons. So summarizing everything is 15 proton, 18 electrons, and 16 neutrons. We will see how much we can manipulate with this. It's like you have to learn how to create a perfect pizza dough just once in your life. Once you create that, you can literally do any kind of work with it. Okay, so what we have done in the second and the third video on this series is we have basically scratched the surface to allow you to get started. Okay, once you get this information, once we actually build on it, you find it so incredibly easy on how to maneuver these numbers around. All right, so stay tuned for the next level of learning, which would involve actually writing electronic configuration and tie this concept into that. All right, so stay tuned.